Guys, welcome back to the final review session here as we work on our preparation for the final exam. This is the last video in the series. I believe it's video number 8, where we will be working on the remaining word problems that were left in the study guide. So let's get right into some examples. Problem number 56 says the design for a new building includes a grand entryway that will be in the shape of a parabola. The proposed plans require the entryway to be 24 feet wide at the bottom and have a maximum height of 18 feet. Write an equation to model the entryway. How close would a 6-foot man stand to the corner, or could a 6-foot man stand to the corner of the entryway? So this entryway is going to be in the shape of a parabola, so I'm going to go ahead and give it a little rough sketch here. So an upside down parabola, this would be like an arch entrance. And it's going to look something like this. Now we need an equation for it, so I'm going to go ahead and put it on a graph. And I'm going to put 0, 0 at the beginning of the arch. Okay, so we know that this point right here is going to be at 0, 0. We know that the parabola or the entryway is going to be 24 feet wide at the bottom. So this gives me a point 24, 0. And we know that it is 18 feet tall. So that actually tells me what the y-coordinate for the vertex is. The vertex would be the highest point here, as it is the turning point of the parabola opening down. The vertex is going to be at a y value of 18. Now remember that all parabolas have an axis of symmetry, and so this axis of symmetry divides the parabola in half essentially. This is going to occur on the x value of 12. So my vertex is going to be at 12, 18. So if in part A I need to write an equation. Remember, an equation can be, for a parabola, can be y equals a times the quantity x minus h squared plus k in vertex form. And this works out nicely because I already know what h and k are. My h would be 12, and my k would be a value of 18. Now I need to find the a value, and in some other examples we looked at a focus and directrix approach to finding an a value. In this example we don't know anything about the focus or the directrix. However, we do know 2 points that lie on the parabola other than the point we were given, and one of them is 24, 0. This gives me an x coordinate and a y coordinate that I can substitute into my equation. So if I substitute in 0 for y and 24 for x, this gives me a problem that I can solve for a. So once I have completed the substitution here, now I can solve for a. So a becomes, the equation becomes now 24 minus 12 would be 12, and 12 squared is 144. So 144a plus 18. And then I can subtract 18. And then divide by 144 to get a by itself. So I'll do that in my calculator. Negative 18 divided by 144. And let's put that in a fraction. It would be negative 1/8. And so my equation that I'm going to work with would be y equals negative 1/8 times x minus 12 quantity squared plus k. Now, this allows me to find an equation for the parabola. I also need to figure out how far away a 6-foot man could stand from the corner. So he could stand at either place. He could stand here, and we know if he's 6 feet tall, the y-coordinate is 6, and we need to find the x-coordinate. Or he could stand on the other corner, in the same concept. The y-coordinate is going to be 6, and we would find the x-coordinate at that location. So we can do this graphically. If you wanted to graph that and find the intersection, you can. We can also do this algebraically. What I could do is substitute in a 6 for the y value because we know his height. And now we can figure out, sorry, k, I wrote down incorrectly here. K should be 18. But now we can use this equation to solve for x. So what I would do here first is subtract 18 from both sides. So that would give me negative 12 equal to negative 1/8 times x minus 12 quantity squared. I would multiply both sides by a -8 to give me 96 equal to x minus 12 quantity squared. And to get x by itself, I need two square roots. So I'd have plus or minus the square root of 96 equals x minus 12. And then add 12 to both sides. So 12 plus or minus roots 96 would give me my values here. So I could do both of these in the calculator, and I'm going to round to 2 decimals here, even though it didn't tell us to. On your test, you'll be allowed to. So if I do 12 plus the square root of 96, this 21 point approximately 8 would be our x value over here. And if I do 12 minus the square root of 96, that gives me the x value to the left, so approximately 2.20, which is easiest to find how far he is from the corner. That would be the x units moving to the left of, or to the right of 0, 0. So he'd stand approximately 2.20 feet from the corner. Let's take a look at another example. Problem 57. In problem 57, this one can be done almost entirely graphically. So it says the below function represents a company's profit margin P in thousands of dollars over a year with respect to month M, where M1 equals January, and there's P of M. We need to sketch a graph to represent the function. So let's input this into our calculator. So I have the entire equation into my calculator. I know this is going to be over the span of a year, so I'm going to take my window and go from x equals 0 to x equals 12. Remember, January is going to be the value 1 on the x-axis. Then I'm going to hit zoom and go down to the 10th option, zoom fit. This will give me a graph that I can sketch. And so I'm going to start with my axes, and I will give some labels for this here in a second, but we're going to start by drawing some axes, and then we can sketch out the general curve that we see here. So it looks, oops, let's get to the pen. And it will look something along the lines of this. So there's 12 on my x, there's 0 on my y. The y coordinate is profit, and this is in thousands of dollars. The x-axis is months, and that's again where January is month number 1. So it says find the months in which the company broke even. So what we need to do is we need to find the zeros of the graph. So if I look at the table, I can come up with 1 here of my table. This would be 6, and I can come up with only 1 on my table, but I see that there's 3, so I can use the second trace key to find my zeros. It's going to ask me for a left bound, so I'm going to put in 1, because that's to the left of this 0, and hit enter. It's going to ask me for a right bound. I'm going to put in 2, because that's to the right of this 0, and hit enter. So this point would be at approximately 1.50. This is 60. And I'm going to do the same thing for my other 0. I'll go over here to the right. Left bound 11 is to the left of that. Right bound 12 would be to the right of that. And I'm not going to guess, just hit enter. And so there it gives me my other 0, 1.5 or 11.50. So find the months in which the company broke even. So during the first, or past the first month, but before the second month. So during January. Then the 6th month would be June. And during the 11th month, not quite to the 12th month, during November, the company broke even. What was the greatest gain during the company incurred during the year? So we need to find our highest value, and this would be over here. We can see it on the graph. I didn't sketch that very well, but I can go to second trace maximum. It's going to ask me for a left bound. I want to point to the left of that peak, so I'm going to choose 7. It's going to ask me for a right bound. I want to point to the right of that peak, so I'll choose 11. It's going to ask me to guess. I'm not going to guess. Now, depending on how well I choose my points, sometimes it'll round very slightly. So let's go ahead and let's round this to 2 decimals. So what is the greatest gain that the company incurred during the year? Remember, this is in thousands, so I'm actually going to take this out a little bit further. It had a gain of $204,431. And let's go to the cents, 36 cents. And it says during which month? If we look at that point, during the 9th month, not quite to the 10th month, so during September. So here, this is a word problem entirely solved on the graphic calculator. Let's take a look at another example. 58. It says 2 high schools are taking a trip to a conference. The first high school rents 4 vans and 2 buses to carry their 118 students. The second high school rents 3 vans and 3 buses for their 153 students. How many students can each van and each bus carry? So let's let V equals van, and let's let B equal bus. So for our first equation, we know that the school rents 4 vans and 2 buses for a total of 118. We know the second equation, the second school represents 3 vans, or rents 3 vans and 3 buses for their 153 students. So here we can work on trying to solve the systems of equations. I'm going to go ahead and use elimination. So let me label these. Let's label this equation A and equation B. What I'm going to do here is try to make one of the coefficients opposites. So to get the coefficients to eliminate, I'm going to take A and multiply A by a -3, and I'm going to multiply B by 2. So -3A would be a -12V minus 6B. And then I'm going to take 118 times -3, which is -354. And then I'm going to double B, so that would be 6V plus 6B equal to 306. So if I add these two together, that's going to give me a -6V equal to -48. And then I can do -6 divided by -48, and this would be 8. So V for the van holds 8 students. And then I can go ahead and substitute this back into one of the equations. So 3 times 8 plus 3b equals 153. 3 times 8 is 24, and I'm going to subtract that from 153. So 3b equals 129, and divide that by 3. And b equals 43. So based on this information, each bus carries 8 students, and each van carries 8 students, and each bus carries 43. So we want to make sure with these word problems that we do put them back into some kind of context. You don't have to write a full sentence, but we do want to make sure we at least include the units that we're working with in the small description. So here's an example of systems of equations. Taking a look at problem 59, it says a local town has a population of 16,474 today. 6 years ago, the same town had a population of 4,326. Assuming the growth was exponential, at what percentage did the population increase each year? Well, we have this equation for our exponential growth, which would be Q of t is equal to Q sub 0, the initial population, times 1 plus, it's a growth, so plus the growth rate to the t power, where t represents time. So what we know is that the population today, which would be the quantity over time, is 16,474. We also know the initial population was 4,326. We're not given the rate, and that's what we want to discover, but we are given that the population, or the length of time from our initial population of 4,326, is 6 years. So what we want to do here is we want to solve for R. We can start by taking 6,474 and dividing that by 4,326. And we can do that in the calculator. Now it's going to give me a decimal. If you want to, you can convert this to a fraction and write it down as a fraction. What I'm going to go ahead and do here is I'm going to write it down as a decimal, but eventually I'm going to go back up and pull that answer into my calculator. So when I need to use that decimal, I'm not going to write it as 3.81. I'm going to use this fraction representation. So this would be equal to 1 plus r to the 6th power. Now we need to get rid of the 6th power, and you can do that by using the 6th root, which is also the 1/6 power. So this would be 3.81 to the 1/6 power, which would be approximately 1 plus r. So then I will go ahead and do that computation here, the 6th root, or the 1/6 power of that approximate 3.81. So 1.24, let's make that 25, is approximately 1 plus r. And then I can subtract 1 here. So r, I'm going to go ahead and run this out to 4 decimal points. 0.2496. The reason I'm going to run this out to 4 decimal points is because I'm going to round to the 100th place of percentage. And to convert to percentage, I need to move that decimal places to that decimal point 2 points to the right. So this would be approximately a 24.96% annual growth. So it increased by approximately 24.96% per year. Let's go ahead and take a look at problem number 60. Problem number 60 is another problem where we can use the graph to answer here. It says a party supply company models the average cost of making party favors, A's of X, where A is the average dollar expenditure per party favor, where X is in thousands of party favors produced. Sketch a graph to represent the average cost of party favors and production as production increases. A typo there. Remember to label axes. So I'm going to go ahead and take this function and input it into my calculator. So I'm using the fraction key, but you can also divide here. Just use a normal division. If you do divide, make sure that you put the numerator in parentheses. And I can go ahead and take a look at the graph. I'm going to adjust my window and make it from, let's say, 0 to, I'm going to make it 0 to 20 for right now, and then hit zoom and go to fit. Now, I just randomly chose 20. If I need to increase that window, I will do so when that time comes. But I can get a sketch at this point. So our window, when we do the graphing, we just want to make sure that the window is large enough that it's going to give us a large enough graph to answer our problems here. So I'm going to go ahead and sketch this. This is in quadrant 1. So I'm going to place down some axes, and I'm going to label these axes. So the X is thousands of party favors. And the y-axis here is in thousands of dollars. So I'm going to go ahead and draw in this graph, and it looks, I don't want it intersecting the y-axis, it looks something like this. And I have this drawn out from 0 to 20 as needed. So in part B, it says use a graph to determine the level of production that will minimize average cost. So we can see that part of the graph right here. So on my graphing calculator, I can go to second trace minimum. It's going to ask me for a left bound. I'm going to choose 1. 1 is to the left of that minimum point. It's going to ask me for a right bound. I'm going to choose 4. 4 is definitely to the right. It's going to ask me to guess. I'm just going to go ahead and hit enter. Now again, because of my choice in points, there's a slight rounding here. So this point is actually 2. So it says use the graph to determine the level of production. Production is the x-axis, and it is in thousands. So 2,000 party favors will minimize the production cost. C says use the graph to identify the level of production that would keep the average cost for making a single party favor below $5.58. So, sorry, this should just be, the y-axis should be average cost in just regular dollars. So what we're going to do here is we're going to go ahead and graph the line 5.58. And here, if we find these intersection points, that's going to give us the level of production. That would give us the average cost of $5.58. So we can hit second, trace, and go down to intersect, and we can start to find those two intersection points. The first intersection point here will be at approximately 558. So we're going to round this down to 7, because if we round up, that's going to be over 558. Rounding down will keep us below. I'm going to go ahead and find the other intersection. So second, trace, intersect. Move it over here to the left side of the graph where they intersect over on the left. Find that intersection point. And this would be approximately, we're going to round it down again. So let's round it down to 0 or 0.057. Remember, the X value is in thousands. So it says to use the graph to identify the level of production that would keep the average cost below $5.58. So we would want to be between 570, so 0.57 times 1,000 would be 570, and 7,000 party favors. So this word problem can be done entirely on the graph. Let's take a look at another example. Problem 61. It says Jacksonville's theater department sold 75 tickets for their opening night of a production. Tickets cost $3 for children, $5 for students, and $7 for adults. If they brought in $411 and twice as many adult tickets were sold as children tickets, how many of each ticket was sold? What we are going to have here is a 3-variable system of equations. So we're eventually going to need 3 equations. Let's start by identifying variables. Let's let A be the number of adults tickets sold. Let's let S, excuse me, be the number of student tickets sold. And let's let C be the number of children tickets sold. So what we know here is that a total of 75 tickets were sold. So A plus S plus C is going to be 75. We also know how much they cost a piece. So adult tickets cost $7. So if 7 times the number of adults tickets plus $5 for students, 5 times the number of student tickets, plus 3 for children, 3 times the number of children tickets would be the total $44.11. The last thing that we know is that twice as many adult tickets were sold as children tickets. So the adult tickets would be equal to 2 times the children tickets. And this is a system of equations that we need to solve. Now let me go ahead and label these equations as A, B, and C. Notice that C only has 2 variables, A and C. So if I can use equation A and B to eliminate S, then I can work with a 2-variable system of equation. So what I'm going to do here is take A and multiply by -5. So -5A, and I'm going to add that to B. So this would be -5A minus 5S minus 5C. And then we can also do 75 times -5, which is -375. And again, we're going to add that to B, which is 7A plus 5S plus 3C equal to 411. So when I do this addition, I will come up with 2A, the S's will cancel out, minus 3C equals -375 plus 411, 36. Now I want to go ahead and I see that I have 2 variables in this system of equations, or in this equation. But I can solve this equation, or this 2-variable equation, by substituting. So I can replace A with 2C. So what this gives me is 2 times 2C minus 3C equals 36. Or 2 times 2C would be 4C minus 3C equals 36. So we know now there are 36 children tickets sold. I need to find out the rest. So what I can do is I can go back to equation B and substitute into equation B. Or sorry, excuse me, equation C. The last equation, because I now know what variable C is. So A would be equal to 2 times 36. I seem to have made a mistake here. Let me try to find that mistake. I found the mistake. Sorry about that. Negative 5C, hopefully you caught this. Negative 5C plus 2C is not 3, or plus 3C is not 3C. It's actually a negative 2C. So this would be 4C minus 2C, which is 2C would equal 36. So C equals 18. There we go. That's better. C is actually 18. So 2 times 18 then would be the value for A. So 36. Now I can go back into maybe equation A and substitute in for A and C, the variables. So 36 plus S plus 18 equals 75. And so I would have 75 and I'd subtract 36 and then subtract 18 to get S by itself. So S would be 21. So what we have here for the final solution, we have 36 adult tickets, 21 student tickets, and 18 children tickets were sold. Finally, the last problem in this packet, number 62. It says Dylan takes out a student loan to pay for his first year of college. Under the assumption that no payments will be made during his 5 years of schooling, the loan will be worth $6,800 upon graduation. If interest is compounded continuously at an annual rate of 3.5 or 5.37%, how much was the initial value of the loan? So our compounded interest equation is A of t is equal to P times e to the RT. Sorry, this is interest compounded continuously. So what we can do here is we can substitute in the amount of the loan upon the graduation. So it's going to be $6,800 upon graduation. We do not know the principal or the initial loan. We do know the rate was 5.35 or 5.37%. So when converted to a decimal, it would be 0.0537. And this would be times 5, as the time is for years. And we know this is an annual rate, and so our time units are equivalent here. So what I can do is a simple division to get P by itself. I'm going to divide both sides by e to the 0.0537 times 5 power. And that would isolate P. So in my calculator, I can do this work. 6,800 divided by e to the 0.0537 times 5 power. And so the principal of this loan would be approximately $5,198.77 was the initial loan. A little bit of an odd number for an initial loan, but nonetheless, this would be the amount of the loan that if it were to incur interest at an annual rate of 5.37% compounded continuously over 5 years, that the loan would be $6,800 at the end of those 5 years. And this is the final problem of our finals review packet. So at this point, you have completed all problems of the study guide, and you should be able to use this to help you on the final exam. As always, thank you guys for tuning in, and I'll see you soon.